Thank you very much. I was just complimenting the organizers that the sequence that we're following is going to work out very well in terms of, you've already heard about dredging techniques and different aquatic disposal, and I'm going to focus mostly on the upland side, where we actually take the contaminated sediment and do the treatment before beneficial reuse. Being from the New Jersey, New York area, if I speak too fast, just raise your hand and I'll be sure to slow down, but I want to make sure we stay on time. Safety, of course, is important. All the dredgers, consultants, clients emphasize that. You heard a little about hydrogen sulfide. When you get to the very contaminated, you're also dealing with chemical risks. So one of the things that we like to do in our rules is prepare a risk assessment for each of the projects. So actually looking at the activity you're going to do. So the dredging has its hazards, but also when you do the treating, you want to make sure as you're spraying the material in that you don't, let's say, create an aerosol, something that can be breathed or absorbed through your eyes. So these are things that we get our safety people involved to really study with the engineers and the actual people doing the work. You get some of your best information from those that are actually doing the activity to create a real safe environment while we're doing the projects. A little background on us. We've been doing this for a little more than 30 years. Many know Boskalis as a worldwide dredger, but the focus here is really the group that I'm in, which is the environmental group. And in the United States and North America, we operate as Stuyvesant Environmental Contracting or Stuyvesant's Projects Realization. We're a specialty subcontractor solely handling the processing of contaminated dredge material. So not dredging it on a particular project or a tender. We would team with a dredger and typically a water treatment company and somebody that's going to handle the ultimate disposal of the material. The overall objectives that we're looking to with contaminated dredge material is really to minimize the contaminated fraction. And both Renee and Tito set it up in that the material goes to your fine particles. So if you have a chemical engineering or civil background, when you look at the geotech properties, they're even more important to us than the chemical properties of the sediment. Because once you look at your grain size analysis or particle size distribution, again, your very highly contaminated materials are going to stick to the fine surface area of the fine particles. And that's the material that typically, has to then go either for further landfilling, maybe incinerating, maybe stabilizing with cement, chemical oxidation you heard. So what we really try to do is separate from a physical point of view the coarse material, the sand and the gravel, and then try to beneficially reuse that material. And I'll give some real life examples on how we've done that. Some of the ways that we can implement this technology would be either on a regional location where we have a lot of experience in that area, in the Netherlands being a small country and actually having legislation that prevents you from landfilling. In the US, we have large problems. We got lots of land. We put everything in the ground, and that mindset is changing. Doing work in Canada, they also are looking at the sustainability of loading up trucks and sending them through cities to go to distant depots or landfills, trying to see how much of that material can be recovered and actually beneficially reused on a particular project. We also get involved in specific design, so looking at the feasibility studies, like many of you consultants, the actual construction, and then it is compatible with other technologies. So it's a simple physical technology, and I'll hit a little bit on the actual techniques. This is a regional management facility. We have one actually in the Port of Rotterdam, in Schiedam, and this is a facility that's been there for 20 years where basically we accept the materials. A lot of our background came from soil management. So, treating soil that was from excavations of construction projects, building of new highways, et cetera. And then again, recovering the sand. Since in the Netherlands, that's, these are valuable commodities. Instead of sending stuff to landfills, the legislation actually encourages you to first look at reuse. And many countries talk about that, but there it's a real proven fact that first you want to try to recover the material. Includes separation steps, testing, and then ultimately being reused in a project, whether it's on the A4 highway or in a construction project. I mentioned the two different options, a mobile unit. These you can think of on the left side as typically standard container size, and you put them together like a Lego block system. and that contains everything that you need to do the separation. On the right side is actually our Fox River project, which I'll talk about in some detail, and that's a large inland river, much like the Rhine, and there is just contamination from 80 years of paper manufacturing, so old pulp and paper mills. Most of our contamination comes from those kind of commercial situations that have been going on since our Industrial Revolution. And until the 70s, hearing the same timelines that the previous gentleman talked about, in the 70s we had our Earth Day. By 1980 we finally had some hazardous waste legislation, followed by our Superfund, which is the really bad sites. And first we addressed soil areas, source material, groundwater, and now the next frontier is really sediments. Everybody's starting to look at what's underwater in many of these ports. The technology, as I said, it's a simple physical separation. This is again, the system with different conveyors and tanks and ultimately clean sand in the back there. Here's how you can feed it, with a simple wheel loader. So this is how we do it at our soil plants. You could do that with sediment, but I'll show you some examples on how we do that. This was a particular project in New Jersey on the Passaic River, a very contaminated river, where basically we fed it from that excavator, a long stick excavator, into the feed hopper up there. And then from there it was actually pumped to the treatment system, let's say 2 kilometers away, by just a pipeline under high pressure, double-walled pipe, so that there wouldn't be an escape of material into the environment. So there's many different ways to feed it, and a lot of this uses very proven, common techniques. The preconditioning step is where we look at the particles in this, larger, 3 centimeter to 30 centimeter. You see them washing out there at the bottom from a rotary drum. Then we also do some more spraying again with water. We recycle the water through our process, and here's another preconditioning step, getting to a smaller material. And then ultimately through hydrocyclones is one potential way to do it. Sand separation down to 63 micron up to 3 millimeters. And just again, simple basic units that are available that have been used in other industries for some time. And basically then you have your separated sand fraction, and I'll show a real life example of a project where we were able to then beneficially reuse that sand in a local infrastructure project. As you get to the fine material and then you add polymer, you see just how dark it is over there, and once you add the chemical, how you're able to concentrate the material. And then from that thickening step, you then would go into either plate and frame filter press. These have been used again in the chemical industry and everything from olive oil to paper industry. And then down below are belt filter presses. So again, standard equipment that's been around, whether it's Siemens, US Filter, GMA, Bill Finger, those kind of companies. Again, proven. A lot of it comes from the water and wastewater treatment industries as well. This is our particular experience that we have 3 different projects that I'll touch on. The Miami River down in Miami, Florida. The Fox River, which runs in the middle of the country and empties out into one of the Great Lakes. And then the Passaic River, which empties out into the New York, New Jersey harbor, so right by New York City. Basically different time frames, everything from an 80-day long project, just a small, we call it hotspot, so where the real contamination was concentrated, to the Fox River project that I'll be visiting again in 2 weeks. And that one has been going on for 7 years and probably has 2 more years of work to be done. You see the first one in Miami was maintenance dredging. You've heard about maintenance dredging projects. And then of course the other 2 are pure environmental cleanup projects, again to handle high levels of pollution. Heavy metals in some case with arsenic, PCBs, which come from any kind of electrical equipment. They were an insulating chemical, long chain carbon compound. And then dioxin, which was actually used in the production of Agent Orange, which was used in the Vietnam War to destroy the jungles during the war. And that particular plant has, as a legacy, all of that material then got dumped into the river. And environmental practice in the 60s and 70s, many of the facilities were demolished and then just pushed over the quay wall. So you find a lot of debris material, which I'm sure you're familiar with in all dredging projects, But when it's contaminated debris, that adds a new level of difficulty, let's say. Processing rates could range from, again, 500 cubic yards a day, done almost, we would say, surgically, like a medical procedure, very carefully, because of the high contamination, not wanting resuspension, turbidity. The dredging was actually conducted within a sheet pile wall, and you saw mention to that. Silt curtains often have their own problems. If it's a river with high current, then you have the curtain moving around, and then so that has impacts also. Right up to the Fox River, which runs about 4,000 cubic yards per day. So it's a very large project. We can take the material for treatment either from mechanical dredging or hydraulic dredging, as you saw examples. And there's times where we've used a mobile plant like in Miami. Fox River, we've used a larger full-scale plant for many years, so built for 10 plus years of processing. To touch on the Miami River, again, this was basically a very sandy river, so lots of good recoverable sand that could come from that material. More than 70% of that dredge material was reused as either landfill cover or used in construction projects. You heard about the horizontal grab bucket and also some of the GPS controls and how fairly accurate they've become with that technology. So that's certainly commonly used on projects such as the GE Hudson, General Electric's project that uses these kind of buckets as well. You can see very tight, you have certain yachts here and a very small, tight little area to work. So we had to dredge, then load it into a barge, take the barge down to where it would be offloaded for further treatment. So you have to worry about the logistics of how you're going to do that. And then as we move that barge down, then we had to use the long stick excavator to empty the barge and then load it into our feed hopper. You can get a feeling of just how narrow a river that was. And as Renee said, some of our experience started in the canals of Amsterdam where, you will find bicycles. Here we found some other interesting things, which I'll mention in a second. The overall mass balance, as I said, was mostly recoverable sand, not a lot of fine silts. 24% of the fine material ended up as filter cake, and that had to go to a landfill. We still haven't found a beneficial reuse of filter cake. That's basically where all your contamination is. So that's going to a secure landfill. These are some of the interesting things we found. Basically grenades, some missiles, unexploded ordnance is what they call it, UXO. But we also found a lot of guns, just like in those TV shows like Miami Vice. When they're being chased, everybody throws a gun off the bridge. So that's another American thing, right? So anywhere you go in the water, there's guns. So that was interesting. You also have some large hurricanes that seem to like to aim at Florida. So we had to take down our process and then put it back up when it was safe for everybody to work. On the bottom left there is sort of like large pieces of coral, very hard material, and then just general debris. You can expect any harbor that's operated for that long, to have a lot of debris. Just to touch on that Agent Orange one, this was the 2378 tetrachlorodibenzoparadioxin, once called the most toxic compound. And that was one where we had to have many precautions to really handle that material safely. 80 days, 500 in situ cubic yards a day, 380 cubic meters, let's say. And basically that was finished in 80 days. That's only the beginning of that cleanup. That river right now is being considered by EPA for a much larger cleanup that could take 10, 15 years. But one message I want to give too is that we have big messes and we try to solve them in a big project way. And the benchmark has really been raised to almost 500,000 cubic meters, you could say, per year of being able to process. So I think initially everyone felt it couldn't be done. It would take 30 years. There isn't the technology, there isn't the equipment, and actually we're showing it. Other companies have shown it, like at the GE Hudson project. So we now see projects like this more and more as being possible. Getting the people to pay for it is the other situation, and that's the other American thing. We have a lot of lawyers, so the lawyers find a way to get the money from the people who did the pollution, whether or not it's their recent problem or something that was there for 50 years ago. So that's something that we see. If the polluting company won't do it, then the government will sometimes do it, and then they'll go after them afterwards to collect the money later. Fox River, beautiful area of Wisconsin, kind of like America's Netherlands. That's where they have all the cheese and the cows. That's where we are for 7 years. 21-kilometer river, 4.5 million cubic yards or 3.4 million cubic meters. And that's how much we're processing per day. It's a fully integrated project from characterization, design, and that's the way I would encourage the consultants and also clients to look at their projects as all those different factors together. It starts, as the previous gentleman said, with properly characterizing what is your problem, not only chemically, but from a geotechnical point of view, and then looking at what's the best equipment for dredging. Do you want to pump it? In this case, they pump 12 miles with booster stations every 1 mile. Then you have to put proper Coast Guard markings so people on a ski-doo don't hit that while they're going slalom through there. So these are all kind of the different considerations when you do a project. There's water treatment, there's the actual treatment and disposal, and again, reuse of the sand. This is our project team. Tetra Tech is the prime contractor. I used to work for them. And then now I'm with Boskalis. And Anchor, who you may have heard of, does a lot of the modeling. URS was also involved with that. And our dredger was a local dredger there, J.F. Brennan, one of the best we've seen in terms of hydraulic dredging in the U.S. This is what they brought, one 10-inch dredge and two, sometimes three, 8-inch. That should be an 8-inch, not an 8-foot dredge. 6,000 gallons a minute was the design, pumping at about 8% solids. So again, we looked at the whole river, the sequence, moving from the most contaminated to the least contaminated, and then moving in that downstream fashion. This was the building that we actually built, and their dredge lines actually come in. These are the pipes going direct feed into our particular system. Pretty impressive, you know, how many, 1.8 million tons of filter cake, 420,000 tons of sand. All this is within a building of 2-3 hectares, air conditioned controlled. You know, the material comes in, screened, dewatered, treated, and then filter cake drops into the trucks to go to the landfill. Water treatment is also a big component that you have to look at, and it was mentioned before, while you wouldn't use water injection, certainly hydraulic generates a lot more water than the mechanical dredging. So while it may be an efficient way of almost vacuuming the contamination very precisely, you do then have to add a lot of cost for the actual treatment of the water before you can discharge it back. First step, we start with a treatability study, actually collect samples, again, look at the chemical characteristics, look at the geotechnical. Then this particular facility was built. Now, not every project is going to need something this large, but this just gives you an idea that you could have a regional center that could handle all of the materials within a port, kind of like we have in Schiedam that handles the material from the Port of Rotterdam. These are the operations, again, showing that we've established a pretty good benchmark, the different split. For time, I won't go into the details, but these will be available, and any questions that you have, certainly I'll be here today and tomorrow. The process goes through, instead of words, I'll just give some pictures. Sand separation in a thickener tank, trying to get it to about a 10% solid slurry before it goes to the actual dewatering devices. Again, using hydrocyclones, as you saw before, going through dewatering screens. Polymer, again, used to create the flocks, pull all the fine material together. That's your contaminated material. Through a pre-thickener tank, again, very large size. The water that comes off is clean, that it can then go through the treatment process back into the river. We also recycle as much as we can for different wash down parts of the process. Basically generate solids of 57% when we're all said and done, and that saves the client rather than shipping moist material, you know. Basically it goes out as a dry filter cake. We have 8 large presses. Those particular ones are made by Andritz in Austria. Cycle time about 65 minutes each, and then after this thing opens up, a 2-meter by 2-meter cake actually drops down into a conveyor. And then out there it comes as filter cake on the left, loaded in trucks. The truck comes a little closer to me and right away gets water sprays all on the tires and everything. We also follow the trucks to make sure that they're going the right speed near schools and all, because you have a big impact on your surrounding community. Beneficial reuse, the last thing I'll touch. And basically, one of the only projects we know of in the United States where they're actually reusing this sand, catching up to the Netherlands 30 years later. You want to remove sand anyway because it reduces wear and tear on your equipment, right? Your pumps, your valves, piping. And there's different opportunities, and then you avoid using landfill space, okay? So it's a good cost savings, but it also makes good sense. This is how much we've generated over the years. We drop it out in the building there where it drains. And basically, we had a sampling protocol. This is very specific, so I won't get into too many details. But as you look at this for your project, it's close coordination with the regulators, and we'll be having a talk on that coming up shortly. So looking at how clean is clean, how clean do you have to get the material? Well, this is how clean we had to get. We had to basically get down below 0.49 parts per million, milligrams per kilogram. Okay, and basically from the fine sand to the coarse sand, our running average on the bottom has been well below that. So this allows that material then to be unrestricted, used in construction projects. And again, just from a physical separation, no magic chemicals or incinerator or anything like that. It's just good quality sand with the contaminants going out in the fines. There's a process we had to follow. You had to have public meetings. You had to provide paperwork. That's not going to be as relevant to you. You'll have your own process in your particular country. But that was to get the regulators to approve and to allow the client to, safely take this material out. This didn't come out too good, but Green Bay empties into Lake Michigan, and basically this is where our sand was going, into an actual highway project where it's used as the road base. So perfect use of that kind of material. And that's it.